Hello there. So I am a couple hours later, and I have been in some meetings over the past couple hours, and now I have 1 hour to do a little work. So I thought I would talk about what I discovered. So there is an open source version of K called Kona. KevinLawler.Kona. So github.com. Kevin Lawler Kona. Yeah, that's the one. So Kona. Kevin Lawler. And it's basically the same language that I use at work, with a few minor exceptions. One of them being that it doesn't have the tree of data, or at least doesn't seem to have the same kind of a tree that we have. But it turns out it has KIPC. I didn't realize that. So where did you see it? Wiki, I guess. Yeah, I think the very first page has a quick reference, and you can see here this is synchronous send and asynchronous send. So I'll give you a quick demo of how that works right now. I actually did recompile this a little bit, because this turns out Kona is 64-bit, and I'm expecting a 32-bit. So for the the Python stuff and for what I'm doing at work, I'll probably change this to be either way. I have a Python implementation of KIPC that I will probably change, and then I'm currently writing a Go implementation of KIPC. Let's demo KIPC here. If you don't know what KIPC is, I'm assuming you're a K developer watching this, or a Go developer who's wandered into the wrong room, or aspiring Go developer. But whatever, you're more than welcome here. Just might be in for a surprise here. All right, so I've got these are old ones that are running. These are old before I recompile. So you can see what happened was I would try to talk to it, and it wasn't working, and I had to make one change to my Python client. When it first connects, it sends like 8 bytes, and I don't know why. We always filled it in with 10 where I work, 1010 Corporation, 1010 Data. I don't know why it says 1010 Data, or not Corp instead of 1010 Data, right? I should say. But as far as I can tell, they're ignored. I don't know what this is yet. I don't know what that's for, but there's just 8 bytes that you send, and Kona doesn't like that. And in fact, there's a comment in the Kona source code somewhere that says, like, on Win32, A3.2 has this 8 bytes. What are they for? We don't know. So yeah, that's part of the protocol. So I removed this for Kona, and then change the port, and then I guess that's it. That's all I did. But it was crashing, and so then I realized that I went in here, and so this is the Kona prompt. So here's 0, here's counting to 10 or whatever. So if you want to say the binary version of that, you get this, which is string, but you want to convert the characters to integers. So integers from characters, binary from data, 0. This gives you the bytes, and so I saw this is like way longer because it's too long. So it's like twice as long. These should be 4. Each little section should be 4. So and this should say 8, but it says 16. And so this is the actual data that we're getting back. So the number. I'm sorry, no. Oops. I just do. I clicked on I clicked on this. It's annoying. Anyway, so yeah, so it's 1, 2, 3, 4, 5, 6, 7, 8. These 8 are the actual number 0, and these are the type code. If we set that to 2, then you'll see a 2 here. And so yeah, they're just twice as long, and so that crashed. But the way it works is you define .m.g You have a namespace, right? So whatever namespace you're in the .k namespace by default. And so if you say x is equal to some number, then .k.x is that number. And apparently you can do that. I didn't think it had a k tree, but apparently it does. And so now a.b is there. But in I guess what Kona, this is Kona. What Kona is lacking is I expect to see D. That tells me I'm in .k, and if I say \d .a, it should put me in that directory, and then I'm in that directory, and any local variables I define would be there. So if I say or if I say sub is equal to some dictionary, that's an empty dictionary, and I should be able to say .k.sub, and now I'm there, and there's no items. But if I say d.k and I say .v, then those are all the things I've defined. I say what is sub is that. So if I say sub.x is something, I say v, and then I say v.k.sub. Oh, not yet implemented. But if I say d, go into the subdirectory and hit v, then it would have x. So I didn't think this existed at all. In fact, the last time I looked at Kona, this was not there at all. But now apparently it has some part of a k tree, but this being the k tree. But it doesn't have the, you can't get out of the .k directory. But you can define things in, no, so you can't do .m, but you have to say bang of .m, because I've defined, so bang gives you the keys of the dictionary, so bang of sub gives you the, so if I say bang of sub here, when I'm in the k directory, it should say that I see the one entry called x. Yeah. Okay. So anyway, m.g is the getter function. So that is that responds to a synchronous request. So what this says to do, curly braces indicate a lambda. So if you say, am I not in RL wrap? Is that my problem? Let's kill this. So we'll say bin RL wrap. Failed to bind because it's because the address is already in use. So we'll just say 1024, a nice power of 2. I don't have this in my thing, but anyway, I ran a file called IPC.k, and how do we read a file? Is that 1 colon? I should know that. I hardly ever read files in K, but 1 colon, 0 colon. So read text file 0 colon F. So if I say 0 colon, and the name of the file being IPC.k, and you can, yeah, so then the, if I say backtick 0 colon, that prints it. So there we go. Yeah, so dyadic 0 colon prints to a file, and then if you put the backtick there, then it prints the standard out. So likewise, backtick 1 colon, 1 colon backtick, I would think that would read a line of text. Oh. I don't know. This is the help. So write binary file, read binary file. Oh. Oh, I see. You say 0 colon backtick, and then say hello, and then you get the string hello. So that's like read line. Right, anyway. So what was I saying? Oh, so now running on this port, I'm running on port 1024 because I put that as a parameter in the command line. So -i, and I said 1024, and then read this file. So RL wrap is read line rapture interpreter in read lines so that you get nice up and down arrow keys and that kind of stuff. Run K for Kona. Listen on port 1024, or the IPC port is 1024, and then run IPC.K, which defines this one thing, as you can see from the this is the source code. So print out the source code of read this file printed as standard out. Nicely formatted. Otherwise, you would get the string. So one comma per line, or one string per line. And so then this formats it nicely. It takes a list of strings, and the comma and the thing is a comma string. It would be it says enlist this. So comma means enlist. So this is a list containing one item. The number 1. Okay. So anyway, if I'm able to call this, if I send an IPC message to this, what it's going to do is the IPC message contains just any data, and so your function, this function here, has a parameter called x. I use the letter x, and if I just say that, it's going to return like an identity. You don't have to define what the if I say x plus y, then you have to give it 2 parameters, and then that. Oh, okay. Well, that's interesting. What? If we say that, and then we say, yeah, I don't know why you can't just do that directly, but that's a bug in Kona. Yeah. But anyway, the point is that x and y, and I think up to z, you can have up to 3 parameters that are just x, y, and z. But if you want to rename it to something different, you can say like a and b. You can explicitly declare parameters that way. This would be the same thing. Give them different names. All right, but anyway, so this is use something called x, 5 : of something gives you the string representation of it as opposed to the, right? So this is it. If you print this, you get that. But if you print the 5 : of it, you get the actual K source code to make that thing. Right, so that actually prints that, and if you put a comma here, then that would wrap that. 5 : returns a string, and then the introduction of the comma on that side takes that string, sticks it in a list, and then backtick : or backtick 0 : says print that list of strings to standard output, 1 per line, with new lines in between. So there you go. Okay, so then getting back to this, that's what the 5 : there does. And so all we're doing, in fact, you now have enough information to understand that line. That m.g. Actually, make this a little bit bigger. I don't want to use it the whole screen here, but so that says .m.g is a function that has 2 statements in it. So the first, you don't know what this means yet, but the first one is print, so backtick 0 : a string, and the string is, I also don't know what dyadic comma does, but you can probably guess. So if you have a, b, you put a comma in between them, you get ab. So that's, and then another comma on the left is, it's kind of like the negative sign, like -5 is -5. Although that's actually a literal here, but like this is. Interesting. I know why it's doing that. So I've completely broken Kona because of the change I made, or because I changed this one line to, where is it? Obviously, this should say -5, right? But it's saying this is the maximum 32-bit integer, signed integer, unsigned integer. So yeah, basically, it's I've broken the representation of integers here. But the point I was going to make was that normally in a normal world, like I guess in this one that doesn't have that change, hey, come here. What the heck? Yes, go. I want to go to that one. So if you say -5, you get the number -5. But if you say -5, 3, 5, 5, 5, you get 3 -5s because this is a function being applied to all those. If you say -5, you get 1 -5 and then a 5 and a 5. So literal, whereas this with the space in it is a function application. The function is negative, is minus, right? And likewise, plus does something, but it doesn't do what you think it does. Can we do this? Oh, yeah, you can. And so plus rotates, transposes an array, transposes an n-dimensional array. Anyway, or whatever. What's my point? My point is that in list, like just as the negative sign can be used as either subtract, 5 minus 2, or 5 -2, be either one of those things. It can be a negative, or it can be a minus, depending on whether it's used dyadically or monadically. And likewise, 5, 2 is the list 5, 2, but monadically, because it just took this number 5, 2, 3, 4, right? Puts that together. But if you have like two lists and you put them together, it does that. You put another one of these in here, then first one is applied to 2, 3, 4. You have the number 5, the number 3, and then you combine that list with the list 2, 3, 4, which is also embedded in a list, and so a scalar, and then anyway, so you have a 3-item list now, right? That's what I'm getting at. You have a 5, a 3. That's the list you start with, and then you embed it to this list that has nothing, right? So there you go. If you know about J, then you'll see that the difference between the main difference, or one of the main differences between A and J, is that A doesn't have the it can be non-rectangular, so it's as if everything is boxed, whereas in J, everything is unboxed unless you explicitly box it. Expect everything to be right, and so in K you have scalars, and then you have one-dimensional vectors, lists or vectors, and then those can be nested, or lists can be nested, and vectors are always one-dimensional, rank 1. Whereas in J, instead of just a vector, you also have any n-dimensional array can just be one simple value. So rank is built into the thing. I'm rambling. This has nothing to do with anything. You're not here for J. All right. So point of all this is still to explain what m.g is. So we're taking this, we make a string that says we're assuming it's a string. It'll fail if you send something that's not a string. And then .x just evaluates the string. So 2 plus 2 is so .x evaluates that string. I don't do any testing to check that it's actually a string. But I would expect this to fail because if you say 0 colon print this, and then the next thing is a 5, yeah, you get a cycle. That should give you an error, but not be trapped. Oh, it failed to bind. So what port am I on right now? Okay. I think maybe those are. There we go. Okay, so now we've got Kona listening on a port, and let's go into KIPC here, and we're going to tell it in the code of all things to. Obviously, this should be a parameter, but so we're going to send it these lines. We're going to define a function. We're going to print hello world, and then call call that function with a symbol as a parameter. So it just, it ignores it. So it just, it'll just print a new line. And then assign a variable called v, and then print the count. Count up to, so this should print the number 0 through 9 if this works. All right, so we go into bash over here, and we're gonna run this. And if I look at the output over here, oh, sorry. There we go. So we're talking to this one, right? Which now that I killed it, it's now using the correct numbers. But if I put and so then the next part of this Python code is basically a loop where you're printing a prompt, and then somewhere in here it reads for the input. So it calls input. So basically, if standard input is has some text waiting on it, then it will read that line. If you type in a line and then it sees it, then it'll read that line, convert whatever you type. So it gives you back a string. Yeah, reads a string. Input reads a string. In ancient times, input would in Python would read a value. Now you have to say raw input if you want. So it reads a string, converts that string to the K message format, the binary format, and then sends the message. And it's a message type 1, meaning we want an answer. So if I do that, then in Python here, I should be able to say 2 plus 2, get back 4, and this is showing me what the message came back as, like how it's encoded. If I just say 5, I should get a 5. I should say 6, I get a 6, and you can see that I think this is what we're expecting, what we've been seeing so far. No, this is what we've been seeing so far. Is that right? No, it's the whole thing, right? This is the whole thing. Oh, yeah, right. Okay. I think this is what we normally see. I think this is what's in the tests. IPC, I don't need me. This. I don't need this. When I added the Kona to this workspace, it like closed the window and changed something. All my terminals were still there, but the tabs are different. Test is where I'm Python code. That's interesting. I would expect this to be exactly the same, but it's not, right? So if we want the number 0, we would do the number 1, right? The number 1. What? Oh, I know what this is. This is running the default thing. If I say 2 plus cat, this first number is going to be a 1. Right? Yeah. So this is a flag, and that's why the error is different. Okay, so let's kill this, and then I want to connect to this one again. So on line 1024 now. Let's reconnect. 1024. Obviously, this is not the right way to configure source code. Let's get rid of these other interpreters. Yeah, so the default hello from K. 2 plus 2. Interesting. But even in this case, I guess it just okay. So this is common in K to have a wrapper. I guess that this when you respond, I hadn't gotten that far yet. What can I do? Show what I want to show. I guess if I say underscore n, that would be nil. Now that would be. It doesn't matter. This is not a. Still 24 bytes. The point I'm making is that this is a list and not a. Like here's the thing saying it's type 1 and the value is 4, and here's it saying type 6, which is nil. And here's the I guess this would be saying it's a somewhere in here it's going to say it's a list. Huh. Because if you return if you said I'll never get 3 things in there. But if say 2, 3, yeah. See, now we've got a whole other list. This is padding, I think. I'm not sure. This should be saying that we have a 2-item list with the numbers 2 and 3. Yeah, so change it to 5 and 7, and we should say 2-item list with the numbers 5 and 7. And if we say 5 and 256 plus 7, then we should see this plus a 1, right? Yeah. And so anyway, all this header, this extra part of the header is saying we're wrapping that in a list, and the list contains a 0 here, which is an error flag. Okay, I guess that makes sense. So I didn't realize that was going to happen. I guess I should have realized that, but KIPC is doing that on our behalf. Maybe my KIPC doesn't do that, but it must because you always have to send a value back, and something could go wrong. So probably that's just the protocol. I don't know. I haven't run this against the actual K that I use in months. So yeah, and I'm not in the. I don't have a license for that version of K on this GitHub environment. Anyway, so yeah, then in if you want to have another version, create a new bash file here, and we can say bin rl wrap and then Kona K, and then you would say here, I want to make a handle that is 3: of this plus what port are we on? Moment 1024. Will this work or not? It didn't like that. And if you don't do it that way, I don't know, that was supposed to work, but it doesn't work. Anyway, so H is that. We now have H, and the H is just handle number 3. So we got back an integer. And then if we say h4 colon banana, then it evaluated that. So we say 2 plus 2, we get 4, and so on. And then in the other one, it should be saying all the stuff that we got. There you go. That's KIPC. And that's what we're doing in, that's what I'm doing in, what's going on here? In Go. And I have about half an hour till my next meeting. So, yeah, I'm going to go ahead and write some Go code now. I've demonstrated what KIPC is. Okay. And I guess we can actually talk to Kona, but we're probably not going to get that far because so far in Go, I have so far only implemented one part of this. I need to implement the DB function. Okay, so I need to implement data or bytes from data, 1, 2, 3, 4, that, and then I need to implement DB. So if this round trips, it should give me 234, right? Yeah. This is not going to round trip, right? Yeah. Because I broke integers, but 234. So these are inversions of each other. Yeah. I did implement so integers from characters gives you this, and then CI gives you this. So I implemented CI already in the test framework, but I called it something else. So in my tests here, I called it this. This is CI, right? Same as that. So I've got this part. You know, I'm able to take a string like this and turn it into this, and then I pass it in. So then so if you have this again, this goes a round trip, right? So you start with this, and then integers from characters, and then characters from integers, and then data from binary, and it should all round trip. So I have that working for a number, and that's what I implemented in the last video. So that actually works, and these are all the tests for that. But I have this working, I don't have this working. So I can't turn a number back into that thing. And so check needs to do 2 things. And the other thing it needs to do is, so we've verified that we can get the result we want. Expect. Oh, hang on. Now I'm confusing myself. All right, so now we want so instead of calling this expect, I'm going to call this value. Normally I say actual and expect, but in this case I want to do both tests, and so we'll call this actual bytes. Nope. Actual value. Yeah, so these are both expectations. So how about this? Expected value and expected bytes. I think we're supposed to use camel case in Go. Okay, so then this would be actual value. Okay, so then we're going to say actual bytes is equal to so okay, call this. Maybe I'll put this in the. Okay. So this is string to data. No, this is string to bytes. This is IC. Yes. Integers from characters. Yes, this is correct. This is K3 IC in K3. And then now we want to implement the other. We want to implement CI as well. So inverse of IC, func CI. I'm just curious if Copilot knows how to do this. Yes, it takes a byte array and gives back a string. Now do it. I believe that's correct. That looks correct to me. Good job, ChatGPT or Copilot. Oh, what's wrong here? Func CI is unused. All right, so now actual bytes equals CI of BD. Actually, it's BD of expected value. I'll make this. I'll go ahead and make this part of the K interface, meaning that it needs to be capitalized, so it's public. First, okay. And I'll put those in the KIPC module. I think. Where did the other one go? I have so little space on the screen. Right, so that in here. These are little helper functions, and that should have loaded all the things. I like how when you save it just fixes all your imports. Okay. So now we say actual bytes. So DBS. Wait, where's DBS? The DB of IC. Let's inline that. So we'll say DB of CI of this. Expected bytes, convert them to characters, then take the bytes and convert it to data. DB IC of S. Oh, IC, right. Wait, what? Right, because a character string, yeah, the character. This is a string in it's kind of weird. Like, is the exact opposite. In like this string is actually an array of bytes, and this is the actual numbers. But in right, so this is actually not IC. This is so this is different because I'm right, because 3 to like integers from characters of hello is this, but I actually want to convert this string. So this is like num whatever I called it before. I gotta give this a different. This is not that. Uh, num string to 2 bytes, which I think is what I actually called it before. So num string nums 2 bytes, num string 2 bytes, and then this is num string 2 bytes. This is bytes to num string. You hit F2, so you get the, so it changes it in both the files, bytes to num. Okay. All right, so I was confusing myself because I was doing this, but this is not actually the same thing. Yeah, and I'm just gonna get rid of this, make that explicit because this is gonna be the only 2 places where that's used. Now BD of expected value, BD does not exist yet, right? That's the problem. Okay. So now we need to implement BD, and this is kind of long and complicated. Can I zoom in on this? I know I can do full screen, but I don't think if I do appearance Zen mode. That's great, but I don't want it to be full screen. Sidebar panel control. Okay. That E. Okay. Yeah, this is kind of long. Okay, if I want the back, I can look at the outline of it. This code is too long. It doesn't fit on the screen. I would, and it's going to get longer. So I don't really like that. Really don't like. That's why I disagree with this choice to put curly braces on their own line. Of course, I'm making it much worse by using a tiny portion of my screen and also making the font bigger so it's visible on YouTube, but whatever. All right, so BD is going to take A3 data. So we're going to say val is any, and then the return value. You can actually give it a name, Buff. You can give your return values a name here. And so we're going to say buff is what? We have to switch on val.type. That's right. Which I think is kind of cool that you can do that in Go. And if it's an int32, then buff is going to be, what would it be? So what are we trying to do? I guess we'll bring this back. So if we want to do the binary from data of the number 5, and then we get that, and then just so we can read that as a byte array, actually these are not bytes, but this is what the bytes should look like. Right? The actual numbers are in 32. 11, am I late? Nope, I've got 20 more minutes. So, all right, so buff is going to be an array of bytes that is exactly this string. Exactly this. At least for the first test case, right? Byte. Well, no, it's not. It's not like that. We want a buff is going to be this place. And we got to put commas here after each. And then we could say byte of this, of the val. And so as long as we're about, why is that? If it knows it's an int32, why would this complain about that? That seems strange. I think you have to do this. I've seen this. You have to say int32, right? Yeah. This little weird type conversion thing. I don't know. And then we have an error here for what? Oh, so then we need a default case. Default. And it will be panic. Oh no! Don't know how to convert value to binary. Okay. And why are you mad now? Missing return. Oh, right. Yeah. So if you just say return and you have a named return value, then you avoid that. You don't have to say what you're returning. Okay, why is this mad? Yeah, but I'm going to do something else. Case share? No, not share. Byte, right? I think a byte would be the same thing. I think it's actually the same logic. I think, but here you have to say it's a byte. But I don't think that converts it, does it? Let's see if that works. Oh, it does. Okay. Except this would be a 3. Well, let's see if that's true or not. So if we say x, so if we say backtick 5, right? Yeah, that's what I expect. They're exactly the same, except this one becomes a 3 because the type code is different. And we could make this explicit by saying byte a3 int, right? And this is byte of k3 character. Maybe we could even show the different fields. Until we get a way to do this. These are the fields. So it's 4 32-bit integers. Or I guess one set of bytes and then the total number of so then so 4 bytes that are just individual bytes, one 32-bit value. This is the endian flag. This tells you now that you know what your endianness is, you can parse these bytes to get the list of the length of the length of the rest of the message. And then that message itself is the first 4 bytes are the type code, and the next 4 bytes, so that's 4 of those 8, and then the next 4 are the actual value. I expect these tests to actually pass now, even though this is a hack. But I think, except maybe the one that I think one of them is a much higher. Oh no, I haven't. So I expect these first 2 tests to pass, and then these 2 will fail because I'm doing something with bytes. It's my code is only going to work for bytes right now. All right, so actual bytes is this, and then if actual bytes is not equal to expected bytes, then t error f. Oh, look at that. Copilot. Very handy. All right, so I expect if I comment this out and comment this out, it should pass. I'm going to delete all these. Well, I'll leave that up. Back over here, get out of here, and just go. You know what? I'll even just make a new thing. You can have as many shells as you want, so why not? And then we just say go test. Nope, we have to say cdk3 IPC and then go test. Go toss. Go test. Go test. Missing return on KIPC Go 100. Oh, it's still missing a return. Oh yeah. So this should this should be down here now. Return. But I don't actually have to use this. I kind of like it better to just say return. I guess if you have a complicated set of whatever in Pascal, which this is heavily inspired by, or Oberon or whatever. Go is inspired by Oberon, which is a reinvention of Pascal by the person Niklaus Wirtz, who made Pascal, and it's I'm like about Oberon, but Pascal had named function parameters, so there was always a thing called results, and you could name the output. I guess Oberon. I'm not sure if Oberon has that or not. All right. I wrote an Oberon compiler once. There we go. Okay, so that did pass. And then I imagine that when I turn these back on, then it will fail. I was going to say this might fail because it's too big of a number, but no, because the leftmost bit is not set, it won't be negative, and so we won't have the issues. There are no issues because I'm not talking to anything. But in the future, there would be issues if you were talking to Kona because I'm not even talking to Kona. Right, so I expect these to fail because they're bigger, right? Right. And so now we need to go. You were looking at the earlier version of this or the previous stream. Golang and bytes. Golang encoding package. I guess encoding bytes or something like that. Oh, encoding JSON and everything. I didn't really look at what was in here, but so you got like different. How do you browse the things that are under encoding? Coding, I see. The JSON and hex and all that kind of fun stuff. Oh, I see. So I would make a IO writer on what is that? put uint put uint 32 into a buffer. Unsigned integers. So I think this is all I need. I don't have to have a writer. All right, so let's say, but now I do need buff, right? So okay, let's go back here. Let's back to calling this buff. You don't have to use it. So if I give it a name, it still should work, or still should compile, still fail. So we will say buff is equal to this. And then we'll say, if I just look at, we say byte order interface. So binary little endian put uint 32. Binary little endian put uint 32 into the buff. Oh, why you say? This actually was correct. How do you make that? So we would do 8, right? 8 clone. I think is what it actually said before. I'm assuming this is little endian, right? Yeah, I think it's everything is little endian right now. Do this as well. Dumb. I don't like that name, endian. Uint 32 buff, and then nd little endian, or not this, nd buff 8. So and then another 4 bytes would be 12. So this is why you would want a writer, right? So that you don't have to do this arithmetic. Then you would say val dot int 32. Int 32. Val dot int 2. Uint 32 of val int 32. Typecast. And then when we return the buff down here, okay. So I need to make this buff equals make byte of 16. 16 of those, right? 4444, yeah, 16. And so interesting. So I have to write it like so we'd say nd0 is 1, and that's this byte, and then nd4 is 8. 8 bytes. And that's short. But not ND, it's buff. 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 Oh, I lost something. Oh. I want that. Duplicate. I think you can alt click and then hit the second. Yeah. That's 8 buff. Okay. 8 bytes. Length of data, 4 byte type, 4 byte plus 4 byte dot. We could just as easily write it like this, though, rather than putting it in that spot. Because the length might be something else. So at 4 column, we'll put how about we say length equals 8, and then we put the okay. So it doesn't assigning the result of this to a variable could eliminate type assertions in switch cases. Oh. So it's saying t, if I say t equals val dot type, and then switch on t, is that what it's saying? This? It didn't like that. That doesn't seem. T declared and not used. I'm not sure what I'm supposed to do. I have to use it somewhere. Right. Assigning the result, which val equals val type. Oh. Which, so you use val equals val type. Interesting. Okay. Okay. That's a weird syntax to me, but there we go. All right, this is still correct, but now we've incorrectly encoded the length and the actual numbers. I would expect this to pass. That's a neat little trick. So val equals val type. So it typecasts basically. It redefines this to a thing of the. Interesting. All right, and all my tests pass. Okay, and I actually am out of time, so that was perfect timing. So there you go. We've done a demo of KIPC, and then we've got a test now where we can round trip all of these numbers to and from these representations. I guess the next episode would be about doing the characters and the strings and filling in the rest of the types. I really feel like this is going to be wrapped up pretty soon. And then at some point today or tomorrow, I'll do a WebSockets in Go, and then you should be able to talk to Kona. So if this works, maybe I'll think about how to do the 32-bit versus 64-bit versions of these of these protocols, and then just talk to native Kona without screwing up Kona. Anyway, I gotta go. So thanks for watching, and see you again soon.